Hi students. In this lecture, I am going to discuss problems from HC Verma. Let us see first one. Two cylindrical vessels of equal cross-sectional area A contain water up to heights H1 and H2. The vessels are interconnected so that the levels in them become equal. Calculate the work done by the force of gravity during the process. The density of water is rho. Let us see how to start. First, let us make a diagram for the given data. Given two cylindrical vessels, identical. Cylinder 1. Next, taking one more. Cylinder 2. Suppose in the left one, level is up to. Suppose it is up to a height of H1. Given H1, let us take the next one. It is up to a height of H2. This is H2 and this is H1. So now connecting these two, they are interconnected. So when we connect like this, a liquid flows from left vessel to the right one until their levels are equal. So let us make now diagram when levels are same. See now what happens. If you observe now these levels, in this level there is no change. Okay, you can see extra part in the left one is H1 minus H2. The extra part is H1 minus H2. So in this part, no change. I make a shading here. So in this part, no change. So here and here, no change. So here extra part is H1 minus H2, extra part. So since both having same areas, so here what happens is half of this water, you can say half of the volume of this water will go on to the next one. That means finally here only a half part will be left. That means we can say a rise in its level. This will be now, this will be H1 minus H2 by 2. And here decrease will be same H1 minus H2 by 2. Okay. So here what we are saying is that half of the extra volume, half of extra volume goes into the right one. That means finally levels are now like this. This is now level. Okay. So here we have to calculate work done by gravity. Okay. Let us take now these cylinders and earth as a system. Then we can write by gravity. Gravity becomes now internal force. Then because of gravity, work done is equal to negative of change in the potential energy. It is negative of change in the potential energy of the system. Let us calculate now potential energy of the system before connecting, after connecting. Okay. Let us take initial value. So here, no change for this part and for this part. Okay. So I'm leaving now these two parts. I am focusing only the extra part. Okay. For this extra part, if you consider this as reference level. So here I'm focusing only the extra part. Okay. Reference level. This is reference level. Then for this remaining part, center of mass will be, let us take the for extra part mass is, take it as where m equal to area into height is h1 minus high h2 extra part. This is extra volume. That volume into density that gives mass of the extra part. Okay. After connecting, half of the mass will come into the right one. Okay. So initially, potential energy m g height. We are taking now center of mass. Okay. Total value h1 minus h2, half of that. h1 minus h2 by 2. This is potential energy of the system before connect. Because I am not taking this part and this part because these are not changing. Okay. Next, coming to final value. Now here, how much mass is left? This is m by 2 and this also m by 2. This extra part m by 2, remaining part here m by 2. Again taking potential energy m by 2 g. Now height of center of mass. Now remaining height is h1 minus h2 by 2. Okay. Now taking center of mass for that. h1 minus h2 by 4. Okay. So I have taken potential energy for this part. Now for this part also same. So I'm taking into 2. Okay. Now 2 and 2 gets cancelled. So what is now change? Change means final value minus initial value. Okay. Delta U. That is final value minus initial value. Then see how much we get. mg into h1 minus h2 by 2. mg into h1 minus h2 by 4. So change is now minus mg h1 minus h2 by 4. That is now change. So now by gravity, work done is equal to negative of that. So this is equal to negative of negative becomes positive. Okay. Right. And you can see in the place of m, you can write this value. So it is now a rho g h1 minus h2 whole square by 4. This is our final answer. Okay. So like this, by calculating change in potential energy, then we have to take it as negative of change in potential energy. Right. Let us see next one. Let's see what is given. A uniform chain of length L and mass m overhangs a horizontal table which is a two-third part on the table. The friction coefficient between the table and the chain is mu. Find the work done by the friction during the period the chain slips off the table. We have to calculate work done by friction during the period the chain slips off the table. So given that two-third part on the table. Now see how to calculate. Let us make a diagram. So that is a table given two third part on the table. So taking two third part, right? This is given two third part 2L upon 3, this length. So we want to calculate work done by friction. Okay. So here what I am doing is I am taking now one element. Let us take now one element from the edge at some distance x, element of length dx. Okay. It is now dx length, right? Now see what we can write. This element has to cover a distance of x to reach now this edge. Okay, x distance. That means because of frictional force, work done on that element. See carefully. Since a chain is slipping, friction will be kinetic. Okay. It is now mu mg, mu, mass of that part of the element, that is m by l into dx, mass of that part of the element, mu mg. This is now frictional force acting on that element. For that element, displacement is x. Okay. So into x, I am taking modulus of displacement into x. This is modulus of the frictional force. This is modulus of displacement. Between these two vectors, angle is 180 because this element is moving right side, but friction is now left side. So cos 180. So this gives us work done by frictional force on that element. Okay. Like this, we have to consider all elements from the edge, means from x equal to 0 up to x equal to 2L by 3. That means we have to integrate. Okay. Now see calculation part. So take constants outside, mu m g upon L cos 180 minus taking outside. Remaining is x dx, x square by 2. We are taking limits now 0 to 2L by 3. Okay. It is now x square by 2. So minus mu mg by 2L. Take limits now. 4L square by 9 minus 0. Right? 1L gets cancelled. 2 times minus 2 by 9 mu mgl. It is minus 2 by 9 mu mgl. Okay. That is our final answer. Right? Let us see next one. Right. See the question given. A box weighing 2000 Newton is to be slowly slid through 20 meter on a straight track having friction coefficient 0.2 with the box. Find the work done by the person pulling the box with a chain at an angle theta with a horizontal. Find the work, find the work when the person has chosen a value of theta which ensures him the minimum magnitude of the force. So here key points, slowly slid. That means net force on the box is 0. Okay. That means we can say one component of the force is a balancing frictional force. Remaining component is now, it is along vertical. Okay. Let us see first part. Right. First of all, make a diagram for given data. So this is a box. We are pulling that box with some force at some angle theta. It is theta. Now we can see condition given slowly, right? First of all, right here, weight. Weight is mg. That is given as now 2000 Newton. Okay. Displacement. Its magnitude is 20 meter along horizontal. Mu value 0.2. Okay. Now you can see F cos theta. It is along horizontal. So first thing, F cos theta, F cos theta, it will balance. It balances frictional force, that is mu k into normal reaction. Okay. And here normal reaction is, if you see along vertical, this has a component that is F sin theta. Normal reaction upwards. So I'm taking n plus F cos theta. Sum of those two should balance mg. Okay. Now in the place of n, I can write minus W minus, it is F sin theta. Okay. Along vertical block has no motion. So net force must be zero along vertical. Therefore, N plus F sin theta is equal to W. Right. Now see what we can write. From this, see what is the value of F. The value of F equal to mu k into W. W means mg upon cos theta plus mu k sin theta. Okay. So we got the value of F. So what is now work done? Okay. Is asking by person. So work done by the person means by this force. So here what I'm writing is condition given that slowly. Slowly means there is no change in kinetic energy. Okay. So I'm writing here work energy theorem. Work done by applied force. Work done by frictional force. Work done by gravitational force. Work done by normal reaction. Sum of all this equal to 0 because delta k is 0. And we can see displacement along horizontal, frictional force along horizontal only, coming to weight along vertical, normal reaction along vertical. Therefore, because of gravitational force, because of normal reaction, no work is done. Okay. Remaining is only by the person and by frictional force. And it is very clear when displacement is right side, frictional force is left side. So by frictional force, work done is negative. So from here I can write work done by the person plus work done by frictional force totally equal to 0. That implies by applied force work done is negative of the work done by frictional force. Okay. Minus by frictional force how much work is done. Frictional force is now or directly I can write here directly because we got here the value of F. Okay. So we can use that. I am taking directly by applied force only. By applied force, force is F modulus value, displacement is S. Between those two angles now theta. into cos theta. Because yes, already given, f value we got here. Okay, substitute values here. Mu k, mu k value how much? It is 0.2. Okay, or simplify this, how much we get here? Mu k 0.2 is 1 by 5, 1 by 5, 1 by 5. This becomes now, this becomes now W. Weight is 2000 upon, it becomes 5 cos theta plus sin theta, right? Just simplify this, okay? 0.2, 0.2 means 1 by 5, 1 by 5, okay? Now substitute this value in this one. 2000 into 20 into cos theta, right? Into cos theta upon 5 cos theta plus sin theta. Or if you take this cos here, 2000 into 20, 40,000 upon 5 plus tan theta. Okay, that is the answer. Now coming to in that second part is second part is he's asking find the work when the person has chosen a value of theta which ensures him the minimum magnitude of force. Students, if you remember while discussing friction, we have learned if there is a block on a horizontal surface, find minimum force to move the block. There we have learned that if this angle theta is equal to angle of friction, okay, then we can move the block with minimum force. Okay, and angle of friction phi equal to, it is tan inverse mu, right? That means here in the place of tan theta, if theta equal to 5, okay, 5 value tan inverse mu value 0.2. That means take tan theta value 0.2. Then we get minimum force. Then work done. So in second case, work done is equal to 40,000 upon 5 plus tan theta. Now theta value how much? Theta equal to 5. I am writing here 5 plus tan 5. Tan 5 value 0.2. So 40,000 upon 5.2. Now making calculation, then we are going to get 7,692 Joule. That is our final answer. Okay. Right.